All right, so let's pick this section up where we left off. Hopefully we noticed, did anyone else notice that this was 2 less? 6 makes 4 triangles, 5 makes 3 triangles, 4 makes 2 triangles, 3 makes 1 triangle. So a 12-sided figure is going to make 10 triangles. Each triangle has an angle sum of 180, so if I take 10 times 180, that's going to give me my angle sum. 10 times 180, 1800. So all the angles added up are 1,800 degrees. Okay. So this leads us into our new theorem, the polygon interior angles theorem. Okay, this isn't a pretty important theorem. Okay. So basically what this tells me is that the sum, again, sum is adding, meaning if you add up all the angles, if you add up all the angles of the interior, of course only the inside angles, of a convex, meaning it doesn't cave in anywhere, a convex polygon, it's n minus 2, 180. So the angle sum S, the sum is n minus 2 times 180, where n is the number of sides. Okay. And again, where this comes from is this is one way of proving it. Here we are noticing this pattern is it's always going to make 2 less triangles than the number of sides. Okay, so we would take n, which in this case, if it's 12-sided, we would take n minus 2, which is 10, and then multiply that by 180. Okay, so that was just what we did up here was basically just this formula without the formula. So here in example 1, if I want to find the sum of the measures of the interior angles of the figure, first thing I need to know is how many sides does this guy have. So we've got, let's see, one side here, 1, 2, 3, 4, 5, 6, 7, 8. It's got 8 sides. Okay. So to find the sum, I take the number of sides minus 2 times 180. So the number of sides, 8 minus 2 times 180. 8 minus 2 is 6. 6 times 180 gives me, so I take 6 times 180, and I end up getting 1,080 degrees. This tells me if I was to add up all of these angles, add up this angle and this angle, I would take all these angles, add up this one, and 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 this one. If I add up all 8 of these angles, because there's 8 of them, if it's got 8 sides, it's got 8 angles, I would get 1,080. It doesn't really tell me what each individual angle is. Okay, so it doesn't tell me each individual angle measure. Okay, but it does tell me what they should add up to. Okay, example 2. Okay, the sum of the measures of the interior angles of a convex polygon is 90. Classify the polygon by the number of sides. Wait. This one tells me the sum is 900. So I know S. This is telling me S is 900. Classify the polygon by the number of sides. This tells me I want to find n, the number of sides. So our equation, S equals n minus 2 times 180. I know S. I know S is 900 equals n minus 2 times 180. So I need to solve this now for n. I could distribute the 180 in. I think I'm going to divide both sides by the 180 first, because it's times 180. Let's divide out. 900 divided by 180 gets me 5. So I have 5 equals n minus 2. So now we'll need to add 2 to both sides. N equals 7. So it's a 7-sided figure. It's got 7 sides, which if you remember, we call that a heptagon. It is a heptagon with its 7 sides. Okay. All right. Next, corollary to the polygon interior angles theorem. And if you remember from previous sections, a corollary is just something that's easily proven from a theorem. So this is really easily proven from this last theorem. It says the sum of the measures of the interior angles of a quadrilateral, again a quadrilateral has 4 sides, is 360. So if I take any 4-sided figure, add up all 4 angles, I get 360 degrees. Okay? And really it just comes from this equation, n minus 2 times 180. When n is 4, 4 minus 2 times 180. 2 times 180 is 360. There, we just proved it. Okay, that's why this is a corollary. Okay, we could do a corollary for every number of sides, but we use quadrilaterals so often, four-sided figures, that's really the only corollary that we have. Okay, find the value of x in the diagram. So here this is 1, 2, 3, four-sided figure. So I know the sum is 360. So if I add up all four sides, 108 plus 121 plus 59 plus x, we get 360 degrees. So now it's just them adding 108 plus 121 plus 59. We get 288 plus x equals 360. So we would subtract 360 minus the 288. That leaves me x is 72 degrees. Okay. All right. A little bit more vocabulary. We've talked about this a little bit before. Equilateral. Lateral is actually Latin for sides. So this actually means equal sides. So an equilateral polygon has all sides congruent. If all the sides are congruent, we call it equilateral. Equiangular, well, that's all angles congruent. Equiangular, all angles are congruent. If a polygon is both equilateral and equiangular, we call it regular. This is a very important word, this regular word. Regular, super important. Great big star, circle it. We will use that a lot. This regular polygon basically means it is equilateral, all sides congruent, and equiangular. All angles congruent. These are the type of polygons we're most familiar with because for some reason in all elementary stuff, most of our polygons are regular. Okay. All right, so here in example 4, a home plate for a baseball field is shown. So here's home plate. It's a 1, 2, 3, 4, 5-sided figure. That's a pentagon. Okay. Is the polygon regular? Explain your reasoning. Well, I don't know anything about the sides, but I do know this is a 90-degree angle. This is a 90-degree angle. This is a 90-degree angle, but these two are not. So is it regular? No, because it's not equiangular. All of the angles are not the same. Okay. Find the measures of angle C and angle E. Well, I know this one's 90, this one's 90, this one's 90. These two both have one arc in them, so they're congruent. So whatever this angle is, I don't know, let's give it x. This one is the same thing. This is a pentagon, a 5-sided figure. So if I add up all 5 angles, the angle sum is going to equal n minus 2 times 180. This is a 5-sided figure, 5 minus 2 times 180. 5 minus 2 is 3, 3 times 180 is 540. So I know the angle sum. If I add up all 5 of these angles, we should get 540. So let's add up all 5 of these angles. We have 90 plus 90 plus 90, so there's 3 90s, 3 times 90, plus x, that's 2 x's, has to equal 540. Okay, 3 times 90 is 270, plus 2x has to equal 540. Let's subtract the 270 from both sides. 540 minus 270 is 270. 2x equals 270. Divide both sides by 2. 270 divided by 2 is 135 degrees. So the measure of angle C is 135 degrees, and the measure of angle E is 135 degrees. So we have C and E. Okay, so that's all us dealing with interior angles. Okay, so now we need to talk a little bit about the exterior angles. How we have an exterior angle again. We did exterior angles of triangles. It's if I extend each of these sides out in one direction, it makes an angle. It makes this angle here if I extend this one out this way. So then this one, I can't extend it this way because it'll cross that one, so I'll have to extend it out this way. Okay, it makes this angle here. Then I'll extend, again, if you extend each one out one direction, Oh, this one would kind of have to guess on where it's at, be right about there. And this one would be out this direction. Okay, it makes that exterior angle. Okay. What's interesting about these exterior angles, okay, so that's what an exterior angle is. We actually have an exterior angle theorem. The bigger the number of sides, the smaller these angles tend to get. And what's super interesting is if I add up all of the exterior angles, again with one angle at each vertex, you will always get 360. Again, this is a pretty important theorem too. It's the polygon exterior angles theorem. If I was to add up all of the exterior angles here, so if I was to add up, again, one angle at each side, you will always get 360. It doesn't matter how many angles there are. Okay, so if I add up all of these orange angles, if I add up this angle, this one, and this one, oh, that one, don't forget that one. If I add up, again, this is 1, 2, 3, 4, 5-sided figure. If I add up these 5 exterior angles, I will get 360 degrees, always. Okay. So here in example 5, here we have, this is a 1, 2, 3, 4-sided figure. So if I add up 4 exterior angles, again, one angle at each vertex, I will get 360 degrees. So if I add up 2x plus 89 plus 67 plus x, I will get 360 degrees. So 2x and x is 3x. 89 plus 67 is 156. Subtract the 156 from both sides. Two, 3x equals 204. Divide both sides by 3. A 68. So x is 68. Okay. All right. So now our one last example. The trampoline shown is shaped like a regular. Ooh, important word there. Regular, regular, regular. What does that tell me? It's equiangular and equilateral. It has all congruent sides, all congruent angles. And dodecagon. Okay. Dodecagon. How many sides does a dodecagon have? If you don't remember, you can look it up. It's 12-sided. Tells me it's got 12 sides. Okay. And so example for part A, it says to find the measure of each interior angle. Okay. I know how to find the measure of the sum. Okay, the sum of all 12 angles is equal to that n minus 2 times 180. So I have to take 12 minus 2 times 180. So that would be 12 minus 2 is 10 times 180. So if I add up all 12 angles, I get 1800, degrees. That's if I add up all 12 angles. I want to find the measure of each interior angle. Well, if you notice here, I'm going to have 12 interior angles. Okay, there are 12 interior angles, each one being the same. So since there are 12 interior angles, and they are all congruent. So basically 12 times the measure of each interior angle is 1800. Or I just need to take the 1800 and divide it evenly among the 12 angles. So take that 1800, divide it evenly among the 12 angles, and I get 150 degrees per angle. And if you look here, that's a pretty obtuse angle there. It makes sense that it'd be 150 degrees. Okay. Now it says find the measure of each exterior angle. Well, since it has 12 interior angles, it's going to have 12 exterior angles. But I know if I add up all the exterior angles, the sum of the 12 exterior angles is always going to be 360. The sum of all the exterior angles is always 360. So I would need to take the 360 and divide it evenly among the 12 angles, and I'd get 30 degrees. Each angle is 30 degrees, which makes sense if you look at the interior ones. The interior angles are 150. The exterior are 130. which if you notice, when you add those two, you get, you guessed it, 180. Because if we draw this exterior, we have a straight line here. This interior angle is 150, this exterior is 30. It makes a straight line, which would make 180 degrees. Okay, so go ahead and write your practice down here on the bottom, and good luck.